here in this case, calculate current in 2 ohm resistance. This is 2 ohm resistance. We are interested in the calculation of current in this. And verify the reciprocity theorem. Now here, how to calculate this current? Current is branch में current कैसे निकालना है? Choice is yours. You can use the mesh analysis, you can use the nodal analysis method, or you can use the Thevenin theorem, Norton theorem, whatever the theorem or whatever the method you know. And take the ratio of this voltage to this current. And then, in the case 2, take this source here and calculate the current here by changing the positions of V and I. And check the ratio. That ratio must be same. Means we are going to verify this reciprocity theorem. This we are planning to verify this reciprocity theorem. I will start with this. That is the case 1. This is the case 1. In case 1, I will consider as it is. Yeah, here in this particular case, I will use the direct inspection method. This is loop 1, its current is I1. This is loop 2, its current is I2. And this is loop 3, its current is I3. Means we are interested in the calculation of ratio of V divided by I3. That is the case 1. If we are going for that, here I will write as per direct inspection method. Direct inspection method. What we have here? We have this matrix. This matrix, which is equal to constant. It is simple. If you have attended all previous lectures, how is the case? How is the case in this particular case? In this case, this formula we will use generally for this calculation. This method. This is R11. This is R12. This is R21. Sorry, R13. This is R21, R22, R23. Then finally R31, R32, and this is R33. We will do this calculation. First, I will start with this R11. Resistance of the first loop. This is first loop. How much is this resistance? 4 plus 4, which is 8. This value is 8. Find out the R22. How is the R22? This is 4 plus 4 plus 8. Means this is 8 plus 8. That is 16. And in this method, only diagonal elements are positive, remaining all elements are negative. And what is the last? This is 8 plus 2. This R33, 8 plus 2 will be, this is 8 plus 2 will be 10. This value is the 10. The resistance which is common for the first and second loop, this resistance is the 4. This is minus 4. This value is minus 4. Then R31 and R13. This is first loop. This is third loop. There is no common element. That's why it is 0. Then R23 and R32. 2, 3. This is second loop. Third loop common resistance is 8. This is minus 8 and this is minus 8. What are the currents? Currents currents are 3. That is I1, I2 and I3. How is the constant for first loop? If we are traveling with the direction of the current, plus 20, 0 and 0. Is it right? If we know this, we are interested in only I3. But here, what I will do, I will find out the I1. I will find out the I2, I will find out the I3, but we are interested only in the calculation of I1. Sorry, I3. सिर्फ हमें I3 चाहिए because इस 2 ohm में जो ratio है, इसका और इसका हमें ratio लेना है. Now I will use the calculator here. I will shift the calculator to the equation mode. I will select the unknowns as a 3. A1 is the 8. How much is the A2? Minus 4. Then 0. How much is the constant? 20. Then it is minus 4, then 16, then minus 8, then 0 again, then 0, then minus 8, then 10, and which is again 0. This is 0. Is it right? I will check the values first and then I will check the answers. A1 8 hai, theek hai. A2 is minus 4, fine. This is 0, fine. This is 20, fine. This is minus 4, fine. This is 16, fine. This is minus 8, fine. This is 0 is fine. This is 0, A3. Then it is minus 8. Then it is 10 and then 0. Okay, fine. Now we have the first answer is 3.15. This is 3.15 amperes is the first current. How much is the I2? 1.31 amperes is the I2. How much is the I3? 1.05 amperes is the I3. Now, in the case 1, we will find out the ratio. How is the ratio? This 20 divided by ratio 1, I will call it as ratio 1. 20 divided by 1.05. How much is this ratio? This is 20 divided by, I will come back to the normal mode. This is 20 divided by 1.05, this value, which is 19. Sorry. Yeah. This is 1.05, that is 19.04. Here, this ratio is 19.04 is the ratio for case 1. And if we are calculating for case 2, just by changing the position of V and I, this ratio must be the same, and that is nothing but the reciprocity theorem. Reciprocity theorem करंट कैलकुलेशंस के लिए यूज नहीं कर सकते हम इसको करते हैं अगर पोजीशंस ऑफ V एंड I अगर इंटरचेंज होता है, उस केस में वेरीफाई करने के लिए हम इस थ्योरम को यूज करते हैं. I will take this figure, new figure here. How will be the new figure here? In this case, its figure will be something like this. This is 4. This is 4. Here it is 8. Then this is 2. Now here I will take this source here with the same polarity. ऊपर पॉजिटिव था, ऊपर ही रखा. ये 20 वोल्ट है. ये करंट का डायरेक्शन नीचे था, इसका भी डायरेक्शन नीचे ही रखा. And here I will draw this figure something like this. This is for case 2. This is figure for case number 2. This is case 2. What we are doing in the case 2? We are changing the positions of V and I. Now here, in this case, I will name this current as I3 dash, this current as I2 dash, and this current as I1 dash. We are interested in I1 dash now. What are the values? This value is 4 ohm. This is 4 ohm. This is 4 ohm again. Is it right? This is 2 ohm again, and this is 8 ohm again. These are the values. Now I will prepare the matrix by direct inspection method. We get by direct inspection method. We get what we get from the direct inspection method. We get this matrix into current matrix is equal to the constant matrix. Now look at इस इम्पेडेंसेस को हमने चेंज नहीं किया है, इसलिए ये जो भी है यहाँ पे आएगा. Because here again I am finding the same value. R11 resistance of the first loop 4 plus 4, which is 8. Resistance of the second loop 8 plus this 8 is 16. Resistance of the third loop, which is this. Then it is a minus 4. This is minus 4. This is 0. This is 0. And then this is minus 8. And this is also minus 8. Because we are not changing any impedance. इसको as it is हम यहाँ पे ले रहे हैं. इसलिए ये मैट्रिक्स आपका चेंज नहीं होगा. Now what are these values? इसकी वैल्यूज है I1 dash, this is I2 dash, and this is I3 dash. What are the constant? If we are traveling with the direction of the current, the first constant is 20, second is 0, third is 0. Now we will find out the currents I1, we will find out the current I2, and we will find out the current I3, which is nothing but I1 dash, I2 dash, and I3 dash. But our interest is this I1 dash because positions of V and I हमने interchange किया है. I will use this calculation again. I will shift the calculator to the equation mode. 3 unknowns. I will enter these values. This A1 is 8. Then next is minus 4. Then next is 0. Then next is 20. Then A2 is minus 4. Then it is 16. Then it is minus 8. This is minus 8. Then again 0. Then again 0. Then again minus 8. Then again 10. And which is again 0. Now look at the values. Now look at the values. Now here in this case, I1 is 3.15. This is 3.15. This is 3.15 amperes. Is it right? This I2, I1 dash is this value. I2, how much is I2? Here in this case, I2 is 1.31 amperes. Is it right? And this is 1.05. This is 1.05 amperes. These are the values. We have changed the positions of V and I. Is it right? And now, if we are
So the wrong one. I3 dash की value 20 होगी.
I3 dash की value. Okay. I3 dash की value कितना है?
मतलब 20 नीचे आएगा ना?
Just I will check. This is A1 correct है 8. This is minus 4. This is 0 and this is 20. Fine. Sorry. यहाँ पे 0 चाहिए, बराबर? और यहाँ पे 20 चाहिए. Now it is correct. Now it is correct, I guess, because in this case ये 0 हो गया, ये 0 हो गया, ये 20. Now it is fine. ये values नहीं होंगे, values will be different. Just I will check once again. I will check once again. Absolutely. Saurabh, बिल्कुल. Then -4, 16, then it is -8, then it is 0, then 0, -8, 10, and then it is 20. I guess this is 20. Yeah, this is X is, or this first value is, this is I1 is 1.05 amperes. The second value is 2.10 amperes, and this third value is 3.68 68 amperes. Now, if we are finding the ratio 2, I will call it as V divided by I1 dash, which is 20 divided by 1.05. Here is also same, 20 divided by 1.05. This it is 19.04 is the ratio. This is the ratio, that's why it is unitless. Means here, this reciprocity theorem is used for the verification of the ratio of the voltage and current in one mesh to the other mesh. That's this lecture today. I will stop here.